So next is thermodynamic equilibrium. Okay, so at first we'll define the state of equilibrium or equilibrium state. Okay, so the system is said to be in equilibrium state if its measurable quantities do not change with time. So suppose if you are observing a system, okay, for some time, and you see that its measurable quantities means suppose the pressure, volume, temperature, then suppose density, etc. These are the measurable quantities or properties, you can say, of this system. Okay, so if these measurable quantities or properties of the system do not change with time, then we can say that the system is in equilibrium state. So the term equilibrium means that a state of balance. So these quantities or the properties of the system in equilibrium state will be in a state of balance. Okay, so now in an equilibrium state there is no unbalanced driving forces which is acting within the system. Okay, so if there is, and sometimes it is also, they are also called potential, there is no unbalanced potential or driving forces within the system when the system is in equilibrium state. So these driving forces, if they are present in a system, they will cause these measurable quantities to change. Okay, they will change the measurable quantities or make them out of balance. Okay, and that will disturb the equilibrium state. So for example, suppose we have over here we have suppose some gas or whatever is system in equilibrium state. Okay, and as you can see throughout the system, okay, the temperature is 30 degrees centigrade. So initially, and suppose you observe the system for some period of time and you see that there is no change in temperature with time. So you can say that initially the system is in equilibrium state with respect to the temperature, or you will see that it is called the thermal equilibrium. Now suppose this equilibrium state is disturbed by supplying some heat to the system. So this supply of heat energy will act like a driving force which will cause this equilibrium to be disturbed. Okay, so this driving force will break this equilibrium state. So now as you can see, as the heat energy is supplied, okay, for suppose some time, you see now the temperature within the system has changed. It is no longer in equilibrium state. So at different point within this system, the temperature is now different. Now suppose the source of heat energy is withdrawn. Okay, so this is the intermediate state. So now what will happen? The heat energy now which is now within the system will spread throughout the system and a new equilibrium state will be reached. That is, the system will achieve a new state where a higher temperature will be achieved at different points within the system. So you see, after the supply of the heat, now the temperature of the system has increased. Okay, and at every point within the system or throughout the system, a new temperature, you can find that there is a new temperature which is now 36 degree centigrade is achieved. Okay, so this is the new equilibrium state. So in this case, the driving force, this heat energy will be acting like a driving force which will disturb the initial equilibrium state. Once this driving force, unbalanced driving force, or these external influence is withdrawn, this system will reach at a achieve a new equilibrium state. Okay, so that the system will have a new equilibrium temperature. Okay, and this new temperature will be same throughout the system, which is now 36 degree centigrade. So now what is thermodynamic equilibrium? So a system is said to be in thermodynamic equilibrium if it is in mechanical, thermal and chemical equilibrium at the same time with its surrounding. So suppose you are observing a system and you see that it is in mechanical equilibrium, at the same time it is also in thermal equilibrium and also as well as in chemical equilibrium with its surrounding. Then you can say that the system is now in thermodynamic equilibrium. So what is the meaning of this chemical equilibrium? Chemical equilibrium means there is no unbalanced force acting within the system or between the system and the surrounding, so that there will be no change in pressure. Throughout the system, the pressure will be same everywhere. Next is thermal equilibrium. So what is thermal equilibrium? So as we have seen that a system is said to be in thermal equilibrium when the temperature is same throughout the system. Okay. And then is chemical equilibrium. So the chemical equilibrium will occur when there is no change in internal structure of the system due to chemical reaction, or there is no mass transfer due to diffusion. Okay, so suppose there is some chemical reaction occurring in the system which will cause the internal structure of the system to change. Okay, or if suppose there is diffusion occurring within the system, okay, then there will be a transfer of mass. Diffusion means suppose in the system in some portion the density is high compared to other portions. So there will be a transfer of mass from higher density region to lower density region. Okay, so this is diffusion. But if no such thing occurs within the system, that is no chemical reaction or no diffusion, okay, then the system is said to be in chemical equilibrium.